Students, today I am starting load and store instructions. Already you know what is load instruction. Load is from memory to register. Okay, so I'm using a mnemonic LDR, loading from memory to register. That's why we use a mnemonic LDR, means only register. So first memory address is present in R1. So in R1 you will have some data, that is 900, means first it will go to the 900 location. In that location whatever data is there, that is loaded into R0. Before this instruction your R0 is having 7. After execution of your instruction, your data is loaded from memory to register R0. Now your R0 is changing from all 07 to 0011 0011. This is nothing but load. Store is from register to memory. So in register R0 I am having 011 00110. Now I want to store this data in R1, but R1 is pointing to some address. So I will go to that address. In that address already I am having some data, that is all zeros 11. So first I will go to that location. Then I will store the contents of R0 into 900 location. So I am storing the contents of R0 to R1, where R1 is pointing to the memory location. So now in 0000900 location you will have the data 01. So here this R1 is nothing but in this location. In this location now you are having a data. In this 900 location you will have this data. Means we are storing from register to memory. This is from memory to register. Now what is LDRB, STRB, LDRH, STRH? B means byte. So load byte from memory to register. Store a byte from register to memory. Again load half word from memory to register. Store half word from register to memory. See, actually ARM is a 32-bit processor. So word length will be 32-bit. So here word means 32-bit. Byte is already fixed, that is 8 bits. Then what is half word? Half word means 16 bits. Okay. Same load and store, same thing you have to do. But here you will having B and H. B indicates byte, H indicates half word. Now multiple load and store. Now here we are loading and storing is done only for one register from memory location to memory location, or from memory location with only one register. But multiple load and store instruction means we are loading from memory to multiple registers. Storing is from multiple registers to memory. So first one LDM. M indicates multiple register. Here R indicates only register. M indicates multiple register. Now R0, this symbol, this indicates it is a pointer. Okay, it is pointing to some memory. So direct memory address we can't give in ARM. Always we have to use load and store instructions. So R0 with exclamatory mark indicates it is a pointer. Now first R0, what is having? 9000. Okay, it is having 9000. Now what I should do? Load from memory. So I will go to first R0. In R0 I will have 9000. In that 9000 location I will have data, this one. So this is how many bits? 32 bits. 32 bits means how many bytes? 4 bytes. That's why after 9000 next address will be 9004. Next it will be 9008. Next it will be 9000C. Okay. So in 9000 I will have all ones, 4, all 2s, 8, all 3s, C, all 4s. Now what I should do? Now I should load from this memory to these registers. Which registers? I should load this data to R1, R2, R3, R4. That's why I write R1 dash R4. So first 9000 it will go. From 9000 it will load this data into R1. Okay. Next it will point to the next location 9004. Why 4 again? Because this is 32-bit. 32-bit means 1 byte is equal to 8 bits. 1 byte is equal to how many bits? 8 bits. So 32 bits means 4 bytes. That's why you have to always add plus 4. Okay. So next it will point to 9004 location. In 9004 location what data you are having? 2, 2, 2, 2, 2, 2, 2, 2. Again this 2, 2, 2 will be loaded into which register? R2. Next 3, 3 will be loaded into R3. Next 4, 4, 4 will be loaded into R4. Means I am loading the data from memory to registers. Which registers? R1, R2, R3, R4. Next, from loading from memory to registers, no, directly I will not write the memory address. I will use one R0 register, which is a pointer. This pointer will specify the address of memory location. Similarly, now store. See, store R0 exclamatory mark, comma R1 dash R4 means I am storing the contents of R1, R2, R3, R4 to memory. I should store the contents of register to memory. I should store from register to memory. So first already I will have R1, R2, R3, R4 some data. R1 I am having all 4s, R2 all 5s, R3 all 6, R4 all 7s, all 7s. Now what I should do? I should store all this register data into memory location. Now R0 is pointing always to some address, so it is now pointing to 8000. So first what I will do? First in 8000 I will store R1 contents. So I am written all 4s. Next it will go points to the next location 8004. In 8004 I should store which contents? R2 content. That's why I write R2. Next it points to 8008. Now I should store which contents? R3. Next again it points to 8000C. Again I should store which contents? R4. Means I am storing R1, R2, R3, R4 to memory. Register to memory. This is registers, this is memory. In this case, this is memory and this is register. I am loading from memory to registers. Here I am storing from register to memory. Always in both the cases, you will have this pointer. R0 is used as a pointer, whereas R1 to R12 registers 13, 14, 15 are used for stack pointer, link register and program counter. No? So remaining R1 to R12 registers you are using for loading and storing. But R0 is only used for pointer. M indicates multiple. Always M indicates multiple. Normal R if you are writing means it is simple. Register to memory, memory to register. Next. Understood up to here? Next, pre-index with write back. See, this is very important. Listen now. First one, R0. I am having all zeros. Next, I am taking R1, 0, 0, 0, 0, 9000. Okay. Next, in 9000, again I am having some memory locations. In 9000, I am using, okay. In 9000, I am using 1, 1, 1, 1, 4, all 2s, 8, all 3s. In this case, I am using R1 as a pointer. In this case, I used R0 as a pointer. So, from R0 to R12 registers, you can use R13, R14 and R15 are used for which one? Stack pointer, link register and PC. So, with remaining all R0 to R12, you can use. In this case, I am using R1 as pointer. In this case, I am using R0 as pointer. See, first one, LDR. R0 comma R1 slash 4. This square bracket indicates indirect addressing mode. Means wherever you want to load the data from memory to register, no, you are loading the data from memory to register, no. So indirect address is present. Wherever you keep square bracket, there you will have indirect address. This is pointer. Now first you will go to R1. What is R1? Pointing to 9000. Next, for that R1, you will add 4. 4 is an immediate data. This is immediate. Pound symbol, no? So, for 9000, you will add 4. Now, it becomes what? 9004. Now, your R1 is updated with 9004. Now, 9004 location, it will go. In 9004 location, what it is having? All 2s. Now, these all 2s are moved to R0. So, in this case, both R0 and R1 are updated. This is nothing but pre-index with write back. Means your register, pointer register is updated and that pointer updated memory location data will be updated in your R0 also. This is nothing but pre-index write back. Next, only pre-index. Now only pre-index schema. In only pre-index, first it will go to R1. What is R1? Pointing to where? R1 is nothing but 9000. First it will go to 9000. Again plus 4. 9004 it is becoming. Next, in 9004 what is data is there? All 2's. So first all 2's will be coming into your R0. But your R1 is not updated. Means it will have only 9000 only. Okay. Means R1 is not updated but R0 is updated. This is called as pre-index. Pre-index means R1 is not updated but R0 you will have updated data. Understood? This is nothing but pre-index. Pre-index write back means both will be updated. Pre-index means data is updated, address is not updated. Next, post-index. Post-index means see. Again, see the notations. In this case, pointer, both adding, then you will have pointer. In this case, no pointer, only you will add, but it is not updated, but that updated data will be present in R1. In this case, see, first it will go to R1. In R1, what is there? 9000. Next what you have to do? 9000 plus 4. R1 is updated. So your address is updated to 9004. But 9004 location data is not present in R0. Only 9000 data is present in R0. Okay. Means here address is updated but data is not updated. Okay. This is not updated. In this case only which is updated? Address is updated, data is not updated. In this case address is not updated, data is updated. But in this case both are updated. This is called as pre-index with write back, pre-index, post-index. These are only used with normal registers, not multiple registers. For multiple registers we don't use this one. Only for register to memory, memory to register case only we use this one. This one understood, no? If you want, again you take one more example and try to solve it. Shall I give one more example? You will try. Okay, I will give one example. You try it and give me the answer. Okay. Wait. After this class, after this one, then I will give one example. You do this one. Okay. This one understood, no? Shall I give one example? Okay. Take this example and solve it. First one, LDR R0, comma, this is pre-index with write back. This is post-index. And this is pre-index. Okay. Now I will give locations. In that locations you write down. See. 2004 8 C 8. Take this as 8. Okay. Okay. So you have to add 8 and then you have to update this one and you do this example and send me the answer. Next listen. This is very important.